Well, it might take the priority.
Okay, so we'll look at some of the examples of the sequence diagrams. But sequence diagram is not the only dynamic or interactive diagram that could represent what happens inside the system. The state diagram, as we already discussed, has states, dynamic states and transitions that take between the states, and usually in response to some sort of event. So the sequence diagram is really effective showing behavior of several objects inside a single use case, right? So, like I said, typically have a use case, perhaps with main case scenario and also alternative type of scenarios, and you can have sequence diagrams that very effectively demonstrate interaction between objects within that single use case. Sequence diagrams are not very effective across multiple use cases because they would simply become too complicated. You know, if you look at the realistic case with the number of objects, it's very quickly becoming very difficult to watch. You know, a lot of interaction. So sometimes they're just like, you know, the sequence diagrams have their own limitation, if you will. So therefore, they're typically, to keep them manageable and brief, it's advisable to use them within a single scenario in a use case. The state diagrams, however, are relatively compact and they can display behavior of a single object across multiple use cases, because a lot of business objects, for instance, survive the execution of a single use case and continue to exist for much longer time, and therefore their behavior internally can be shown by the state diagram. And activity diagrams are good to show general sequence of activities for several objects and multiple use cases. So activity diagrams are more like flow charts. However, they can have parts that execute in parallel. So therefore, they're effective to show essentially a number of activities that take place, and they may be a sequence of multiple use cases. Why activity diagrams are more effective in multiple use case situation compared to sequence diagrams? Because they're much less detailed than the sequence diagrams. Sequence diagrams are detailed to individual objects and individual methods that are being called, whereas activity diagrams basically loosely tell you the decisions that are being made internally, and instead of naming individual objects, instead they choose to name it as an activity. And then the sequence diagram can be used to talk about individual objects within that activity. So later on we'll see examples of that. So another set of essentials specific to the sequence diagram. So essentially these are just highlights of many things we already said. Use case typically represents single scenario. The sequence diagram usually represents a single scenario within the use case. A sequence diagrams shows possible implementation and oftentimes can be used to reconstruct the implementation, to reconstruct the actual dynamic interaction between the objects of an existing software. So we discussed the lifelines, right? So we will say that at the top we have, across the top here, we have the objects that participate in sequence diagram. We call them participants because they participate in this type of interaction. Each single one of them has a lifeline. And it's interesting that sometimes I may want to instead of displaying just the interaction, maybe I would like to also show that perhaps in my situation, I'm thinking about this entire arrangement that I have, and let me move this call to the top, right? Call to the top, and move this to the top as well. I'll probably just have to rewrite the name of my method over here. Just clean this up and rewrite this method call. So perhaps what I have is again back to initialize use case. Okay, and so this is the initial method call. So this is our activation bar, which I made longer, and I'll tell you why I made it longer. Because sometimes I would like to display, sometimes I would like to display that, sometimes I would like to display that controller could be creating the interface, and it could be also creating the database. If I wanted to show the creation, my choices are that perhaps what I could do is, so this is the lifeline, right? The lifelines exist for these objects, but they do not necessarily represent the existence of an object. So it's very typical that on sequence diagrams, if you would like to show that controller creates the interface, what you can do is that you can basically display it with another arrow that represents a message from controller to the interface, and what you can say here is new, right? Remember that we can use new when we create objects, and so from here we can show that the object is actually created. This object is actually created by us saying new, and that would be an example of, essentially the example of a sequence diagram that uses the visualizes creation of the interface class. How? Because we can use new. There is even better way to display creation. Oftentimes, and this is very popular type of display. Let me just essentially resize this a little bit, like this, right? So what I can also do with respect to this new, I can actually move this box representing an individual object directly down here, okay? And basically this would give a pretty good visual clue to the observer, to the viewer of my diagram, that what happens here is that we say new, right? And you can direct this new arrow straight to the box that represents the new object. So here we have someone is calling initialize use case. This is a method that belongs to the controller. What controller first does is basically creates the interface, right? It says new interface and creates the object that represents a window or some sort of other type of interface for the for our view part of the model view controller. Similarly, I can also create my database, right? So I can similarly say that the controller may also be responsible for the creation of the database object. So similarly, I can grab my database object and say that controller also creates, at this point, somewhere here, controller also creates the database. So again, the very typical structure of a sequence diagram where you want to display creation of objects. Again, this time the arrow goes this way, and I can say new and display the fact that I create the object. When we have this creational messages part of our sequence diagram, it's also very typical to extend the activation bar directly to the name of the instance of our object, like this. And when we do that, essentially we have a single activation bar that connects the object with object box with its activation bar. Okay, so these are possibilities or varieties of improvements, examples of things that we can improve in our sequence diagrams, so that right now you should sense that it's pretty clear that controller creates an interface, controller creates a database, then calls get key, gets the key apparently, then calls get data, and the database supposedly provides the data, right? Also, one final note on the creation. Sometimes when this database object, for example, is already is no longer needed by the controller who created it, it's possible to indicate directly on this diagram. It's possible to also indicate directly on this diagram that we want to be able to indicate that the life cycle of this object ends at this point. You can display it by using big X like this. Big X represents the fact that the database object is destroyed at this point. Okay, so this is clearly an indication that, okay, that's the end of this life cycle. We're no longer interested in using this object. Apparently, we created it as new object, used it by calling get data, got the data back, and then the object is being destroyed. Okay. Now, there is also another little aspect to this is that when this is the case, in C++, in Java, you typically don't explicitly destroy objects. Instead, you essentially, as long as there are no outstanding references to a specific object, it will be garbage collected. So this would be a very typical Java, Java display here. However, in C++, when you create objects as new, you also have the delete version, the delete operator, which may destroy objects. In that case, you can indicate who destroys this object by using the arrow pointing to this X and saying delete, right? So you can indicate that it's the controller that says, now I want to delete the database object, and that's just another part of component of sequence diagram that we can use to indicate that kind of dynamic. So you can see that now the version of the sequence diagram that we modified and improved, hopefully, shows us so much more than the class diagram, which simply used to rely on boxes and say, look, we have these classes with these specific methods, and that's pretty much, this was pretty much the whole if you will, structure. However, that structure did not indicate dynamically in time how exactly these objects interact. Of course, when on your class diagram you display connections between classes, it indicates that they know of each other, right? They can interact, but it doesn't say in what order they interact. Whereas on the sequence diagram, now you can tell the entire story of the interaction. Who does what, and what happens first and what happens next, who creates who destroys who, this is essentially much more elaborate, if you will, to display the dynamics and interaction of specific instances. The limitation, on the other hand, of sequence diagram is that if you have multiple scenarios, for instance, this specific diagram, you can say that it is it's sort of like an indicator of a normal normal use case scenario, right? Main scenario. It doesn't do anything to indicate that perhaps in the alternative situation, what happens if the database fails to get the data? What if something happens to the database server? What if it doesn't, if it doesn't interact, if it fails to interact with the database and signals some kind of error message, right? The sequence diagram does not have if-else. It's not capable to show decision making. It just says, okay, it's possible to have this type of normal case scenario. For alternative case scenario, you have to essentially clone this diagram and modify it to show what happens if the database connection fails, and you have to somehow display alternative information to the user. Display them the error message, ask them what they do, what they would like to do in a case, would they like to retry or exit, and so forth. It's very different, right? So it's a little hard with respect to sequence diagrams that they just have to, multiple versions of them may exist to display different type of interaction. Again, to bring this all in order, you can use activity diagram to link together main case scenarios, alternative case scenarios within the same use case, and even link together multiple use cases. So sequence diagram does have its own limitations. Although very effectively shows creation of objects, sequence of methods that we call and so forth, at the same time that is not very effective showing us any sort of decision making which imposes a certain limitation on this diagram. So after this quick demonstration, just a quick rundown on this. So we have the participants, right? So we have the participants over here. If I might try to display it side by side, we can see parts of this, right? So each participant has a lifeline, which is this thing. The ordering of messages sent across object lifelines is interpreted by reading down the page, right? So we say that the timeline goes down this way. Each lifeline has an activation bar. So these are our examples. Those gray areas are activation bars that shows certain operations actually taking place during the entire interaction. Return arrows are optional. So the return arrows are typically displayed with the dash line, whereas the actual initial message call is typically shown with the solid line with arrows. And it says here, in most cases, sequence notation is self-explanatory, especially when there is a not very long list of objects interacting. However, when there's a longer list of objects interacting, which would then require perhaps, horizontal scrolling of this diagram, it's a little more difficult to deal with. Perhaps then the solution is to actually print it and have a bigger, essentially examine it as a hard copy, not on screen, because especially, vertical scrolling is more or less okay, whereas horizontal scrolling is difficult. It's not very effective to deal with those. The bottom line is the good diagram should be readable by all intended audiences, right? So if you're trying to display the sequence diagram to clarify some ideas to your stakeholders or expert users, perhaps you can even simplify your diagram to omit some details. At the same time, if you're trying to debug the application and find the cause of specific problem, you probably wouldn't want to do that, and in fact you want to see a lot more details. So it really depends on your audience. So the diagrams can be tweaked and adjusted as necessary because your audiences can be different, including yourself. You're part of the audience. Sequence diagram participants, we already mentioned that we use the colon to separate the name of an object from the class. In our demonstration here, controller interface and the database are unnamed object. Basically, we say it doesn't matter what are the actual names of these objects in software, they're just interacting classes.